Okay, folks, so this is example 3.1, and they're expecting you to use that equation that we just derived for this example. Okay, so we're going to use theta, the angle of ascent, is equal to thrust minus drag over weight. Okay, remember this is for small angles. So first thing you always do with a problem like this is you circle the things that are given to you, okay? So we have a lift to drag ratio of 15, okay? Lift to drag of 15. So what that lift to drag ratio is basically how much lift you get for a given amount of drag. So L over D, okay? Ratio is one thing divided by another thing. So if you have a high value for lift drag, it means the aircraft glides efficiently. So gliders will have a high lift to drag ratio. Okay, and we have a thrust to weight ratio of 0.25. Okay, so how much thrust for a given amount of weight for the aircraft. Okay, so they're the two things that you're given. So we're going to use this equation. Now you might be saying to yourself, we don't have a weight for this question. We don't have thrust, and we don't have drag. Okay, so obviously we need to do something with this equation. Okay, so what they've done for this example is they've gone theta is equal to thrust over weight minus drag over lift. Now you might be saying, how have they gotten to that equation? Well, we know from when we were deriving these equations that weight is approximately equal to lift, okay, for small theta, okay? So that's how we've gotten this equation to change to that value, because we've said that's approximately equal to that, okay? So, because this equation, if you wanted to rewrite it the long way, would be theta equals T minus D all over W, okay? So all they've done is they've crossed out one of those W's and then turned it into an L, okay? That's how we've got to this point here. Are we all clear with that? I'm hoping we are. Okay, so now we've got T over W, which is thrust over weight, which is our thrust ratio, okay? And we know that because we have a thrust to weight ratio of 0.25. So we can go theta is equal to 0.25. And then we say minus, now this is drag over lift. We're given a lift to drag ratio. This is a drag to lift ratio. So if you were to flip this and find the reciprocal, it's like saying 1 over 15, because the reciprocal of this is lift over drag. Okay, so we have to take the reciprocal. So we know that lift to drag is 15, so drag to lift is 1 over 15, the reciprocal. Okay, so when you do the mathematics for that, you'll get a ratio, a value of theta that's in radians, okay? And we get our little calculator out, our scientific calculator, and if we say 0.25 minus 1 divided by 15, and goes equals, we end up with 0.183 repeater. Radians. Okay, they might ask you for degrees, okay? It's probably better to convert it to degrees. So how do I convert that value to degrees? Well, we know it's in radians. So what you do is you just go shift and then you push this answer button, the DRG, which stands for degrees, radians, and gradient, okay, which don't use that much. And we hit that, and now it gives you the options. 1 is degrees, 2 is radians, 3 is gradient. But you actually, because we were in degree mode, you think you'd hit 1 for degrees. You don't, okay? You need to hit 2, okay? Because you're telling it that it's actually a radian value, okay? And then you hit equals, and you end up with 10.5 degrees, okay? And the book says 10.3, so I don't know how they got that. I think they rounded, okay? So 10.5 degrees, okay? The other way you could do it, if you want to remember that a radian is equal to 57.29 degrees, you could multiply by 57.29. So if we took this as an approximation and we went 0.183 times 57.29, we end up with 10.5 still. So good on you. I don't think it's 10.3. Okay. So that is the answer. Theta is equal to 10.5, and they're the manipulations of the equation to get that example correct. You could play around with this question till the cows come home, change thrusts, change lift to drag, etc., etc. It's always going to be the same type of question, but isn't it? Now we'll do the next question in another video.